This tutorial describes the operation of the device HM112 Fluid Mechanics Trainer for incompressible flow operations. This instrument is utilized to understand the physics of internal flow in straight pipes, bends, fittings, and flow controlling devices by performing measurements of head loss and pressure differences. Briefly, the system operates in a closed water circuit that includes a water pump, storage tank, a rotometer, multiple interchangeable pipes and fittings, and measuring devices. The input volumetric flow is controlled manually with the valve located to the left of the rotometer. The connection between pipe sections, measuring ports, and pressure gauges is made with quick disconnect fittings. The objective of this lab section is to understand the physics of internal flow, perform flow, head loss, and pressure measurements, calculate friction factors, and draw engineering-based comparisons and conclusions. The main components of the fluid mechanics trainer are: the storage tank holds the water that circulates through the system. Spring water should be used. The pump circulates the water across the entire system. The flow control valve and the return valve allow water circulation through the system. For the device to operate, both valves must be open. A main switch that powers the entire system and another one for the pump. The rotometer, also known as a variable area flow meter, is used to set the desired volumetric flow rate. The flow rate is controlled manually by a valve to the left of the rotometer. An analog thermometer located next to the rotometer continuously displays the fluid temperature. The fluid temperature will be used to calculate the fluid properties. The following components can be utilized to measure pressure and pressure differentials. Two double manometers located to the left of the rotometer can be utilized to measure the head loss between 2 points in the system. The measuring range of these manometers is from 0 to 680 millimeters of water column, which is about 67 millibar. Next, a 6-tube manometer with measuring range from 0 to 390 millimeters of water column, which is about 38 millibar. Next, the differential pressure sensors, which can measure pressure differentials up to 200 millibar. The differential pressure value is shown in the first of the pressure displays. The following pressure sensors have 6 connections with an operational range between 0 and 600 millibar. The pressure magnitudes are shown in the lower 6 pressure displays. Several external accessories can be installed into the device, for example, pitot tube, nozzle, and orifice to measure volumetric flow, various types of valves to measure their opening characteristics, a venturi tube to demonstrate the conservation of energy in fluid flow. See the device's manual and ask the instructor for more details. In this video, we are going to describe an experiment to measure pressure loss or head loss at volumetric flow rate of 1 meter cubed per hour in a straight pipe. Note that additional flow rates can be required for other laboratory activities. Refer to the laboratory guide for specific details. Before operating the machine, make sure to wear safety goggles and adhere to laboratory safety rules. To begin, ensure the water control valve located to the right of the rotometer is closed. Connect the feed and drain hoses to the desired pipes for experimentation. Now, turn the device on by rotating the main switch. Open the return valve located on the pipe in the table. Switch on the pump. Open the control valve slightly to ensure that water is flowing. Carefully adjust the knob to a high volumetric flow rate and wait 2 minutes for bubbles to escape and pressure to stabilize. Once all bubbles have been removed from the system, adjust the valve knob until the volumetric flow rate specified in your laboratory guide is displayed. In order to accurately read the water flow, you must read at the top of the float in the rotometer. To measure the head loss, the double manometer will be used. To start, turn off the water valve and close the return valve. Connect the hoses from the measuring ports to the manometer ports. If the pump is off, turn it on. Open the gray bleed valve. Around 2 turns, only the top knob should be untightened. Slowly open the control water valve. Water should flow up the manometers, through the hose at the top, and down to the water collection pan. Make sure bubbles clear from the hoses. Close the gray bleed valve. Close flow control valve. Open return valve. Open white bleed valve to allow air to enter the manometers. Bleed the manometers until water levels balance. Make sure the levels are low enough to allow measurements at a high flow rate. Levels around 8 centimeters should work. Wait a few seconds if necessary, and/or pinch the hoses to help the water levels to balance. Close the white bleed valve. Set the volumetric flow to the desired value. Measure heights H1 and H2. Units are centimeters or millimeters. Record the values collected. Repeat the bleeding procedure when performing measurements of a new pipe. Ensure all measurements and data collection is complete. We are now ready to shut off the machine. To begin, turn off the pump. Close the control valve. Turn off the main switch.